A 800 kilo-ohms transmission line has per phase line inductance as 1.1 millihenry per kilometer, whereas per phase capacitance is 11.68 nanofarad per kilometer. Ignoring the length of the line, its steady state power transfer capability in megawatt is. Now, what is steady state power transfer capability? Which is equal to V square by ZC. Now, what is ZC here? ZC is square root of L by C. So, this is square root of L is 1.1 into 10 power minus 3 divided by 11.68 into 10 power minus 12. Okay, so power is equal to V square is given as 800 kilovolts. Since we have to find in megawatt, unit will be 800 into 10 power 3 whole square, which is 800 square into megawatt divided by ZC. Okay, you will get the answer as 2085 megawatt, which is option C.
RLC circuit, Vs is 400 volts, which is RMS value, and R equals to 20 ohms, and inductive reactance is 40 ohms, and capacitive reactance is 40 ohms. We have to calculate the Q factor of the series RLC circuit. Here, in the data itself, they have given as XL equals to XC. That means the circuit is at resonance. In that case, the Q factor is omega naught L by R. Omega naught L is nothing but XL by R. XL is 40 divided by 20, which is equals to 2. That is, option A is correct. Comes to the second part B, the voltage across the inductor. VL is nothing but IXL into 90 degrees. Here XL is 40. I is nothing but 400 volts VRMS divided by 20, that is 20, which is nothing but 20 into 40 at 90 degrees, which is 800 at 90 degrees. That is, option A is correct.
Series motor is supplied from single phase half control rectifier. Single phase half control rectifier is nothing but single phase semi converter. Okay, so we have a semi converter which is of single phase. Okay, converter means it is converting AC to DC. At the output side we have a DC series motor. Okay, this is DC series motor. Here we have a field winding in series to the DC motor. Now let us take, this is the output voltage to the motor, to the converter, and this is the input voltage, terminal voltage to the motor. Okay, now he has supplied 230 volts 50 Hz from the input side of the single phase half controlled rectifier. The armature and field resistance together is, he has given it as 0.25 ohm, and load torque T is equal to 25 Newton meter. Neglect damping and motor constant at rated conditions is, okay, he has given some constant K is equal to 0.25. This is volt per ampere per radians per second. Okay, this is the data given by him. What we have to find? We have to find average armature current, okay, for a terminal voltage of 210 volts. At the same applied voltage, what is the speed of the motor? Okay, now let us see the first question here. Now, output voltage of the converter is equal to terminal voltage, that is input voltage to the motor, DC series motor. Output voltage of single phase half control semi converter is given as Vm by pi into 1 plus cos alpha. Okay, now what is the terminal voltage of the motor? Terminal voltage of a DC series motor is given as EB plus IA into RA plus RSC, since it is of series motor. Now what is EB here? EB is equal to back EMF. In series motor we can write with some constant K into, okay, IA into omega M plus IA times of RA plus RSC. Okay, now what is the terminal voltage applied to the in motor? It is given as 210 volts. So this is 210 is equal to, okay, IA times of I can write K into omega M plus RA plus RSC. Okay, now what we have to find? We have to find average armature current. Okay, we know that torque is equal to some constant K into IA square for DC series motor. Okay, this is up to saturation. After saturation, Ia remains constant, torque is directly proportional to only armature current. Generally in DC motor it is directly proportional to square of armature current. Okay, now what is the constant value he has given? Constant value is given as 0.25. Okay, rated torque is 25 Newton meter into Ia square. From this I can find average armature current as square root of 100, which is equal to 10 amperes, which is option A. Okay, now next question, at the same applied voltage what is the speed of the motor? At the same applied voltage 210 volts, now what is the speed of the motor? So 210 is equal to this equation. Okay, Ia value got it as 10 amperes, constant K is 0.25. Okay, omega m is 2 pi into n by 60 plus Ra plus Rsc is equal to 0.25. From this we can find n value as 793 rpm, which is option B.
The initial contents of DE and HL page are given as 5472H and 4528H respectively, and all the flags are set initially. So for the following program we have to find out the following, we have to answer the following questions. The value of the accumulator after the execution of the program RET. So we have to find out the accumulator content after the execution of the program. Here in the first case what we are trying to do is we are performing EL addition and then after we performing DH addition. So after complete addition we are keeping MVI. Before executing a written instruction we are loading A with 00. So the accumulator must contain the 00 before means after execution of written instruction. So the data is not going to be affected after written instruction. So option A is correct. Comes to the carry flag is set to. See, after the written instruction the carry flag is depends upon the last arithmetic instruction before execution of RET. The rotate left carry, rotate accumulator left. So is here this is the accumulator content here 1 to 8, because accumulator is an 8-bit resistor. This is a carry flag. This is D7th bit, D0 bit. RLC instruction keeps the D7 in carry as well as here. So D7 bit before performing RLC, accumulator contains 00H. So 0 is going to be pushed into the carry before written instruction. So after execution also carry flags are not going to be affected because of written instruction. So option A is correct.
Kilovolt 50 Hz single phase cable has a diameter of 20 mm. That means let us take, we have a single phase single core cable. Okay, diameter is 20 mm, so radius is 10 mm and an internal sheath radius of 15 mm. Okay, the sheath radius is given from center of the core to the sheath as 15 mm. Okay, radius is 15 mm. If the dielectric has relative permittivity of 2.4, okay, this is, he has given it as 2.4, so epsilon r is equal to 2.4. okay, now and a loss angle of 0.031 radians, so delta is loss angle, that is 0.031 radians. If the length of the cable is 2.5 kilometers, okay, length he has given as 2.5 kilometers, then the capacitance of the cable is, we have to find the capacitance of the cable. Now what is the capacitance of the cable? Capacitance of a cable is given as 2 pi epsilon naught epsilon r by ln capital R by small r. Capital R is radius from center of the core to the sheath, small r is radius of the core. Okay, This one is core, whereas this is sheath in the cable. Okay, this is farad per meters. Now this 2 pi into epsilon naught is 8.854. I can write this one as into 10 power minus 12 into 2.4 divided by ln capital R by small r. Capital R value is 15 mm divided by small r radius is 10 mm. Okay, this is farad per meter. Now you can find it this one as 0.329 microfarad per kilometer. Okay, now he asked capacitance of a cable for 2.5 kilometers, so this is 0.329 into 2.5, which is equal to 0.823 microfarad is the answer. Okay, option B. Now what is the second question? If the no load current is approximately taken as charging current, then the value of charging current is, okay, charging current is given as IC is equal to V into omega C, or you can write this one as V by XC. Okay, now what is the value of V there? V is equal to 11 kilovolts. Okay, omega is 2 pi into F. F is 50 hertz into capacitance value is 0.823, 0.823 into 10 power minus 6 farad into single phase line, so we should not divide by root 3. Okay, directly this is single phase line, RMS value is 11 kilovolts. Okay, you can find it this one as 2.84 amperes, which is option A.